Good afternoon, everyone. We are the Eagle Consulting team, and today we will be presenting you with extending flight route planning with machine learning to your company, Jepson, a subsidiary of the Boeing company. We will be taking you through the current flight planning system. According to the instrument flight routes, every flight before takeoff has to register a flight plan at the air traffic controller in the airport, which will include details regarding the route to be followed during the flight. The route is determined based on the prior assumptions of the weather and conditions. All of these are done by the pilot, and the flight plan will comprise of all the navigational fixes over which the aircraft will fly and the segments of airways that will be utilized. After the flight plan generation, the air traffic controller system will verify the route and the plan and provide a clearance and approval before the flight proceeds to take off. After the approval, the flight takes off and the pilot is expected to navigate the aircraft along the agreed upon route. So the issues with this current system is that the flight plan depends on the weather forecast that might be changed by the time of the takeoff. It will be a sudden change and the pilot will have to manually change the flight plan that have been generated previously. The flight plan also does not change automatically with the new weather information in flight. This poses a new problem as well, as the pilot will have to manually change and the traffic controller will have to provide a clearance for another round of flight plan generation. So these are the current states of the non-optimized flight route planning system and the costs associated with it. We have analyzed Boeing's 10 largest customers such as Southwest Airlines, Delta Airlines, and American Airlines and highlighted some of the problems that they are currently facing, as can be seen from the slide. So we are aware that there are also external problems that can affect these airlines as well, such as the flight delays due to airport traffic, but we have focused more on the problems internally, especially the aviation planning system. So, as you can see, there are 4 major problems that our clients are currently facing, such as the flight delays, inefficient use of fuel, robustness of network to service disruptions, and also the network traffic flow capacity. For taking flight delays as an example, like our major client Southwest Airlines experiences about 34% flight delays in the recent years. And that might be because of the inefficient route planning system that they currently have. Besides, 33% of the operation costs of the major airlines are particularly is on fuel. So, optimizing the flight route planning system will also minimize the usage of fuel and also can reduce the cost of our clients as well. Besides, there are also the robustness of network to service disruptions and the network's traffic flow capacity. Airlines of America also reported that all of these disruptions cost airlines and passengers about $16.6 billion in 2017, which is about 7.4% increase from 2016. And the root cause of all of this are found to be of the road selection decisions. So this is the existing aviation route planning systems and the problems. Understanding the problems that our clients faced previously will be important to better improve our existing route planning system. As you may all have been aware, your sister company, 4Flight, also have been developing flight route planning system for the general aviation, and hence we will only focus on Jepson Jet Planner Pro that are already embedded for commercial aviation. So the issues with Jet Planner Pro is that conventional route planning system is limited by capabilities of the developer. And the system does not improve over time with more flight planning experience, and hence we are offering you with solution to embed machine learning with the flight route planning system for Jepson. As has been brought to your attention in our previous slides, most of the route planning is done in accordance with humans, and the decision making is solely dependent on human intelligence, which is sometimes time consuming and error prone. We believe that artificial intelligence capabilities could be embedded in these controllers to make quick decisions and be free from human interventions. But before we go on to explaining how AI can help to improve your current flight planning system, we would like to briefly explain the technology behind these implementations, just to make sure that everyone is on the same page. The fundamental technology of this route planning is artificial intelligence and machine learning. Based on the definition of Russell and Norvig in 2009, artificial intelligence is a technique which enables machines to think humanly, act humanly, think rationally, and act rationally. And machine learning is just a subset of AI technique which uses data and statistical methods to enable the machine to improve the experience. We will be focusing on the machine learning usage in the next slides for our flight planning system. In a recent McKinsey & Company report, machine learning is said to be a major approach to realize artificial intelligence by learning from and making data-driven predictions. So, a computer program is said to learn from the experience E with respect to some class of task T and performance measure P. If its performance at task T is measured by P, improves with experience E. So, we will be focusing on mainly these three elements of experience, task, and performance of machine learning. And in the next slide, we will explain how we can embed these three elements to better predict the flight route planning with machine learning. This is the high-level implementation suggestion of machine learning in flight route planning for Jepsen that are developed by us, the Eagle Consulting team. By augmenting the traditional trajectory prediction logic with machine learning, a considerable amount of improvement to accuracy can be achieved. So based on the three main elements of machine learning that are mentioned previously, the task of the new system should take three different kinds of information: weather data, pilot input, and plane's flight data. So the weather data includes meteorological terminal aviation routine weather report, terminal aerodrome forecasts, prognostic charts, and wind and temperature forecasts. The system would also use pilot reports filed to the air traffic control authorities and pilot data input via the electronic flight bag. The computer system and sensors on the airplane will provide flight information and characteristics to the route planning system, such as the attitude and heading reference systems, air data computer, and transponder automatic dependent surveillance broadcasts. And then we will move on to the second part of the task, which is to use all of the information mentioned to make predictions of the best flight route for fuel efficiency and turbulence-free passenger experience. The route will also be available to the pilot, dispatcher, to the air traffic controller, and entered into the autopilot system. During the flight until landing, the autopilot system will report the performance measure of P of flighting time, fuel consumptions, and turbulence data back to Jepsen Cloud Server for further machine learning model training. The experience consists with all flight conducted with new Jepsen machine learning based flight route planning system and will be improving over time. So how to implement the machine learning flight planning solution? Jepsen as a software company can choose between using the state-of-the-art managed service or open source software library for building machine learning models, or hiring a machine learning service providers to custom build the machine learning infrastructure for Jepsen. Using the managed service such as Microsoft Azure Machine Learning Studio or open source software libraries such as TensorFlow allow Jepsen's engineering team to have a full authority on the development process of the machine learning models. Azure Machine Learning Studio and TensorFlow already provides all the necessary machine learning algorithms, and therefore Jepsen do not need to have a specialized machine learning personnel for the development. This method provides Jepsen with more control but would take longer than the hiring machine learning service provider. There are also other alternatives such as machine learning providers such as Pixel, Crayons, and AlexcoData. The machine learning service provider would use the same managed service and machine learning library from Microsoft and TensorFlow to develop the machine learning model for Jepsen. Pixel Crayons and AlexcoData are end-to-end service provider who would help to use and build your entire system. Hence, we can rely on those expertise for the machine learning development. There are several use cases that have already been implementing machine learning-based solution into their route planning system. So, one of which is Orient Overseas Container Line, which is a Hong Kong company, where they implemented machine learning-based shipping route planning system that developed by Microsoft. The system also used vessel speed and weather data to optimize the container ship routing. OOCL also estimated that there will be 10 million costs saved by using the machine learning for route optimization. Another will be Zasti Artificial Intelligence, which helps aviation and also marine companies and its insurers in predicting the risk and eliminating inefficiencies. This could pose some of the advantages to Jepsen, which Jepsen could definitely leverage in the market. There are several advantages that Jepsen could enjoy by having this machine learning route optimization. According to our research, the machine learning route optimization improved profit by 16%. This will be a lucrative market as it will definitely improve Boeing's client satisfaction, and Jepsen could even sell this to a wide network usage. Another one will be improve the pilot experiences as it will be reducing the pilot workload. Passenger experiences will also be enhanced as flight will be smoothened by avoiding hazardous weather and also turbulence. Traveling time will also be reduced by unnecessary diversion and delay. Last one will be fuel efficiency will also be improved as it will reduce the greenhouse carbon emission and operation costs to improve corporate earnings. A new operating model reduces the vehicle usage, route times, distance traveled, and related costs. Aside from the advantages that Jepsen could enjoy, there are also potential issues that need to be highlighted. Pilots might rely too much on the automated technology as it will reduce the operational situational awareness and create significant workload challenges when the systems fail. Pilots who fly with auto-thread engage can quickly lose the habit of scanning speed indications. Therefore, when the AT disengages, whether by design or following a malfunction, the pilot will not notice or react to even large speed deviations. Another potential issues that are associated with implementing this machine-based learning will be the deteriorating pilot skill lessons. Basic manual and cognitive flying skills can decline because of the lack of practice and feel for the aircraft. Finally, after profound evaluation and analysis, as well as the implementation suggestion, we strongly believe that Jepsen should extend the flight route planning with machine learning. We can provide you with our feasibility report that covers the detailed demand analysis, detailed cost, organization aspects, prototypes, and the risk assessments in our next meeting. We think that Jepsen has the resources and capabilities to transform the technology in the aviation industry and become the pioneer of this innovation. Thank you so much for your attention, and please do not hesitate to contact us should you need more details from our presentations.